Welcome to Technical Insights Track 2. My name is Charlotte Dryden. I'm moderating this session all day today. I work at Intel Corporation where I lead a visual computing solutions team. And before I introduce our next speakers, I want to remind you to fill out those surveys that are in your packets. I'm being nudged quite a bit to remind you, and I haven't done it so far. So please remember to fill out your surveys and give feedback to the team on how the conference is going. So the next speakers, there are two speakers for this next presentation. They're from Ring, and they'll be presenting Designing Home Monitoring Cameras for Scale. So I'd like to welcome Changsoo, Jeong, and Ilya Brailovskiy.
Go ahead. Hello, everyone. My name is Changsoo. I've been working for Ring like a little over 5 years. I am in charge of developing the algorithm on Ring security camera. Ilya and I will present some of design aspects, some challenges, objective of security camera. Okay, before I start, like, how many of you ever heard about Ring before? Oh, quite a lot, yeah. How many of you are actually using the Ring products? Oh, okay. I do see some of a business opportunity for people. Okay. Let's start with the Ring introduction video so you can see what the Ring is doing it right now.
At Ring, we have over 1 million happy customers. And today I brought one to help me install some more.
Let's get to work, Jamie.
Let's do this.
Let's make these neighborhoods safe.
We proved at the LAPD that having 10% of the homes with Rings, we're able to reduce crime by 50% in a neighborhood.
Who is it?
It's Shaq and Jamie, ma'am.
I give hugs.
So Shaq and I just put this up for you. We got a new camera, floodlight, motion detection. Here's the view from it.
Great teamwork.
How you like the floodlight cameras?
I like it. I want to see the whole yard.
That's perfect. There we go.
Nice little speaker. What you got in there?
It's fantastic. The picture. I can see him. I can see everything that's going on. It's awesome. I can be anywhere and see who comes to my door.
Look at that, Shaq. The whole backyard. You can see
Look at that.
that.
That's nice.
Isn't that beautiful?
All right, Shaq, I see you and Jamie. Hold up.
You've been busted. It works. I love making neighborhoods safe. We're always home, baby.
Yeah, that's pretty instructive video for our product and service. So the Ring provide like a whole bunch of different camera solutions. Like mainly, we do provide battery-operated camera as well as the like always powered camera solutions. The Ring Video Doorbell is the first generation we provide. It's a totally wire-free, battery-operated wireless communication camera. And then the Spotlight Cam, we provide like a battery-operated as well as the powered, depending on the user use cases. The Ring Video Doorbell Pro on the right side is the powered, always on, through the doorbell power, 12 volt for like a 24 volt AC doorbell power. And then the floodlight camera, as you can see in the video, it's a full-fledged, like big floodlight on top of the camera, so we can turn on the camera as well as the light when we're detecting something. And then we recently released the indoor and outdoor camera, so you can use it indoor as well as the outdoor. So all of our product provide the weatherproof, so you can use it on indoor and outdoor, depending on the conditions. So speaking of the Ring's goal for designing the security camera, the first thing is the image clarity. So we should provide really clear pictures to the users. So daytime, we do have such a different exposure controls, mixtures, as well as for the battery cameras. Since the battery camera is in standby mode at the beginning, and then if you detect something on the sensors, then we boot up and then start capturing the video and then start streaming. So it's a different challenges. And the nighttime vision is always challenging for the security camera. The motion is pretty important. Motion is important just because Ring is not like 24-hour streaming company. We do detect a motion and then we start streaming. So we have a battery device motion detection algorithm. It's a different than the full power motion algorithm. The power device motion detection is different than the battery device just because it is always on, so we can deploy higher level computer vision algorithm on the camera, edge and the cloud. And then the video is important. So like speaking of the video, even though image is pretty clear, we are streaming the video data through the Wi-Fi condition. So, I mean, Wi-Fi is good and bad all the time. Yeah, when my kids are streaming the Netflix, it's different. So compressions, and then the streaming is the key thing, and then the another thing is like how do we deliver all the packets without any packet loss through the server? That's important. So I will hand over about the image stuff to Ilya.
Thanks, Changsoo, for setting up the discussion here. And there are a lot of great cameras out there these days. And you might be wondering why it is even hard to make a new camera. And I think there are many answers to this question, and I'll try to give you some of my opinion on that subject. And of course, all those things that are well known and well architected in many solutions are important, and things like number of pixels, pixel size, and all those great things are very important. But what is probably more important, that the technology itself is evolving. We're seeing better and better pixels from different sensor vendors. We're seeing more power-efficient sensors. We're observing different improvements in the dynamic range. And also with that, we see that expectations from the customers in terms of what the image quality is constantly rising. Because of that, it's a constant innovation in how you put together the sensor, the lens, the entire camera architecture, and how you model the best dynamic range conditions for your camera. And of course, lenses are important. Lenses is your eyes. This is how your camera sees things. And in the past, the best lenses were all glasses. But these days, there's so many new materials, there's so many new technologies, and how you put those components together is also bringing another new dimension in how you can make a better camera. Last but not least, we shouldn't forget about the software that controls the whole camera architecture. And things like dynamic behavior, like cropping, resizing, like tuning, adjusting blanking states, and things like that. Actually, that's what makes your camera work best for the customer, react best to what's changing, and adapt to the situations. So, Changsoo already mentioned that we work not only on line power devices, but on battery power devices. And battery power devices, they have their own challenges compared to devices that are on all the time. Battery devices are waking up just to deliver the video for you. So when they're waking up, coming to think about this, you need to actually initialize the camera, and you need to boot it up. You need to, bring it up to speed. And actually, this takes time. And it's important that when you design the camera system, that you think about this type of behaviors, how quickly it boots up, how quickly it initializes, and things like that. The other thing is, once you have this camera up and running, this is not it. You need to actually get the exposure right. You need to get the color right. And this is what is probably similar between home cameras and mobile cameras. This is not a very new problem, but for mobile cameras with a limited ISP and camera capacity, it's a little more probably challenging than for bigger smartphone cameras, but this is also very important to address when designing those things. And another interesting beast is dynamic range, and usually it's addressed by using so-called HDR technique. For better operated cameras, this is also a double-sided sword, because HDR might take a little more extra power than you want, and it also can impact motion detection. Now, we're security cameras, right? So we need to provide an image regardless what, day, night, rate, and shine. So, and it's a special challenge when it comes to night mode. And this is real footage from one of our customers. And you see it's black and white. It's night mode. And it's not an ideal photography. Like you probably, it's very hard to win a photographer's award with that, but it does the trick. Our customer can see that something went wrong with the Amazon delivery box, and what we are learning from this video, aside from stealing is a bad thing, it's that actually black and white images are very, very useful, and how you would achieve that during the night. Unfortunately, sensors are not that great for implementing night vision in a color, so we can use IR illumination to illuminate the scene, and we can use different techniques, so-called IR cut filter, or different type of sensors called RGB IR sensors, to achieve this night vision capacity. So it's also important to get this night vision right. You really want to be in night vision when it is dark, and you want to present full color image when there's enough light. So how you transition into this night vision is also important. We use sometimes ambient light sensors, sometimes we use the pixel, sometimes we use fusion, whatever works the best. And of course the tuning, I was talking about this, is very, very important. You need to correctly set the frame rate, the image tuning parameters, HDR, on, off, whatever you are using, you should tune it. And last, very interesting aspect, so in terms of the lens capacity, there is so-called thing as a focal shift for different light frequency. And for light spectrum, that is IR, sometimes it could be out of focus if main RGB part of the scene is in focus. So you need to carefully design around those things. You either need to decide if you want to do some kind of dynamic focusing capacity, or you want to actually pick up the right lens for the solution. With that, this is just a few thoughts on the image quality aspects, and I'm turning floors back to Changsoo.
Okay, now let me introduce some of the aspect of the Ring camera's motion detection algorithm. So I will first need to mention that our mission is to reduce the crime in neighborhood. And then the Ring is a security solution company, not the doorbell company. Yeah, so Ring is providing the total solution of the security product, including the security camera, doorbell, security system, like recently the smart light, to help the security concerns. For designing the algorithm, the instant motion detection on the camera is pretty important for us. So real-time detection on the edge and then the cloud design is important for us. And then, of course, we're more focusing on the edge device algorithm, because it's a few more bucks, BOM cost increase, but it's free on top of that. If we design the better algorithm on that. And then another aspect of a motion algorithm design is instant motion alert to neighbors, users. So we need to send the motion alert and then live video in real time to neighbors. So as you saw the video, the previous video, yeah, the homeowner need to react in real time. Yeah, we need to deliver the real time video and alert. And then as a security camera company, the high recall is kind of our objective for designing the algorithm. So like we shouldn't miss any of those security events at all. So speaking of a battery device algorithm, since it is pretty limited, the capability of the device, excuse me. So the battery device is in standby mode at first, and then we deployed the PIR-based algorithm to wake up and then start streaming. Because the pure PIR algorithm has a pretty low power consumption, so we can, stand by and then use the device with a 1 full charge of the battery for at least like 6 months. Mm-hmm. And then the pure PIR algorithm does have some benefit compared to the like computer vision algorithm because it doesn't affect by the IQ. So day-night time, it doesn't matter. The uniqueness of Ring battery device algorithm is we provide the motion zone selection on the different angles, like by 3 PIR. So I will explain a little more detail in the following slide for that. So we do provide the motion zone selection as well as the sensitivity selection. So the user can try to avoid to detect like unnecessary or the unwanted motions other than the human in your door. And then we do implemented a lot of different methods to filter out the false alarm by signal comparison and signal delta comparison on the 3 PIR sensors. So a little more detail on the battery device algorithm. So we do have a PIR array, especially like depending on the product type, we do apply like 1 PIR to 3 PIR. And then the PIR processor is like waking up and then grab the PIR signal and then analyze it. Depending on the situation, if it detects new real objects, the system, like the PIR processor send the signal to wake up the device and then start capturing the images and then streaming it. It's an energy-based algorithm. For the PIR algorithm design, the Fresnel lens design is a key. So how do we capture the PIR energy from the environment to the sensor is pretty important. So we do have all the custom Fresnel lens design on our camera. And the benefit is PIR sensor is usually really sensitive to detect an object like up to 50 feet away. Low powered, so we don't need to worry about the power consumption on PIR sensors. But it does have lots of difficulties for us. The first one is it's a 1D signal, so it doesn't give us any kind of like object information, the object type, size, distance, and directions, speed or anything. And then it's also difficult to design the correct lens. So this is how we developed the 3 PIR algorithm on a battery device. So we do have a 3 PIR. Each PIR had about like 110 field of view. So we do have lots of different overlap between the 3 PIR. So we can make a different zone, which is like the occupied by 1 PIR, occupied by 2, or the 3 overlaps, and so on. So we can provide the user to select, if user are suffering to detect like passing cars, if you're living in like pretty busy street, then they can just like try to turn it off on that direction and then still detect the different directions. And then we estimate, because we do have a 3 PIR sensors, we do have some level of information that how an object is moving through the different zones. So we implemented some of sun glare like filtering, as well as some unwanted like a passing car detection by speed estimation on how fast or speed object was moving from one to the other sensors. as you may know, all of the PIR sensor does have a 2 element in it. So it just creates a signal by detecting a different IR radiation on 2 elements. But it does have some issues for the approaching motions because it didn't create a lot of differences between those 2 elements if an object is approaching. So it's a known issue for the PIR sensor. So we implemented some higher level algorithm on the PIR. So trajectory analysis is one, and then the zone trajectory, the trajectory analysis with whether the signal is keep increasing or that keep decreasing. The other part of the algorithm for ring is the power device. We call it a powered inline power, depending on the really low power line doorbell line or the 110 volt 240 volt full power. The power device is always on, so the camera is always on. So we adapt the computer vision algorithm on the background as well as the PIR algorithm too. It's a 24 running device, and then we didn't have any IQ issues except the initialization time. The benefit of having this algorithm type, we provide the customer to select the really customized motion zone in the images. It provide a big difference in terms of performance, improving the performance of our algorithm, as well as try to filter out unnecessary detections. Again, we do have more than 4 million devices on the field. So we trained our neural network with our data. So our customized the CNN classifier makes a really useful selection to detect only a human. Uniqueness of our algorithm is again providing the custom motion zone, so to filter out the false alarm, and then the PIR plus CV fusion, and then validation is the key for our algorithm. So this is brief block diagram for our camera. On the bottom, the image sensor is kept capturing the images, and then computer vision algorithm is working on. There are more detail. We just implemented background modeling and foreground extractions, object formations, tracking, and then classifications. And then the PIR on the other side, the PIR sensor is good for validate the computer vision algorithm, especially on low light condition or the night time. So in nighttime, computer vision algorithm is, it's fairly good working in daytime with the pretty fairly good lighting condition, but it can be suffered by light changes on the nighttime because it doesn't know anything about that. But in that case, the PIR sensor does provide some some informations that whether it is a real object or not, because the light change doesn't trigger the PIR sensors. Still, the difficulty for us is, as Ilya mentioned, the IQ failed, the CV algorithm is failed. So still, there are a lot of different challenges of our customers' lighting conditions, and then other challenges. And then for designing the really good edge algorithm, we do have some limited CPU on the edges, and then small resolution. We couldn't process full-fledged YOLO V3 algorithm on edge yet. So we're working on. And then nighttime light changes, depending on our own light, on the external light, it's just still a challenges. So this is kind of how do we deal with the motion zone. So this is my old house. The yellow region is user can just draw 8-point polygon point to draw the random motion zone. So I don't I don't care what happened on my front street, passing car or anything on my neighbor's house. Only care about my front yard. And then depending on the object size, motion zone, consistencies, we do provide simple motion slider to change the sensitivity of motion detection algorithm. But behind that, behind the simple 5-point slider, we do have 15 different parameters, to change. Again, PIR sensor does help a lot of force, filtering the force alarm by the light changes. Okay. So the next is the video.
Yeah, so now we got the picture, we detected that we have a motion event, and we would like to show our video to our customers. So I would like to quickly walk you through life cycle of a frame once it got generated until it get delivered to the user. So, okay, we have happy event that we got this nice Amazon box here, and our PIR sensor and our motion detection algorithm detected it. As Changsoo just explained, it's going to take some time to confirm that this is actually something real. It's not a mouse or something. So, and after we confirm that there is a real event, so it's going to be a few moments when we actually get connected to the cloud. After we have this connection going, we are ready to start streaming those frames to our customers, and in a short while, voila, users can see what's happening in front of their door. So this time between when actual event is happening and when the users can see it, I call latency. And of course, we would like to reduce this latency to 0. It's probably not possible to make it actually 0, but there are a lot of interesting ways how we can make sure that customers can see all the interesting frames. Okay, and I'm just going to describe a few of those methods, how it is possible to achieve. Okay, one quite straightforward method, okay, let's stream everything all the time. Let's just do it, yeah. But it's a great solution if you have infinite resources. Your uplink is not constrained, and you have infinite power on your devices and all those great things. And it works in some cases. The other option would be to connect all the time, but stream only when the event is actually happening. Okay, we're doing much better on network capacity, we're doing much better on uplink efficiency and things like that, but it's a possibility that maybe some frames going to be missed, and we really don't know what the cost in terms of those keeping up with this connection would be in terms of the cloud compute and the device compute. Okay, what you can do, and this is, in my opinion, best solution, you can do so-called pre-roll. You can record in a cyclic buffer all the time. And when the event is happening, you can actually start streaming from a little bit before the event had happened. And you can stream all the frames right before the event is happening and a little bit after that. And this technique I call pre-roll. And of course, there are some challenges with this approach as well. How do you stream these extra frames and how do you achieve that? But it's something that can be worked around. You can do it either out of band, you can do it in band with some accelerated streaming depending on network conditions. But of course, in all those situations, two things to remember. First of all, you need to know your bandwidth condition, because you don't really want to stream more than your uplink can afford, and this dynamic bandwidth adaptation is a very critical part of the whole system. And the second thing is you need to be very mindful when you design certain solutions for battery-operated devices. We already talked about this a few times before, and I just can't reiterate. Most of those solutions just won't work for battery-operated devices because of the power constraints, and you need to be very, very creative to get these things right for battery-operated devices. So this is pretty much it. I just would like to give a very quick summary of what we just talked about. Image quality is very important. We take it very, very seriously, and we look into all the new best materials that are available. And software, I can't say more. You can't give too much flexibility to the software. So then motion algorithms are important, and using PIR arrays instead of PIRs is a great way of improving the accuracy, and maybe using some fusion algorithms is another way of improving your accuracy. And it's very important to get the frames right. You need to get the best compression possible, and you need to be very mindful about this whole streaming architecture that you have. And of course, we believe that going forward, the current usages of machine learning and CV algorithms is just the very beginning of what we can see in the very, very near future. We actually think that it's a lot of innovation going on in all dimensions of the technology. We're expecting better and more sensitive PIR sensors. We actually expect it will be more innovation even in lens space. We're going to get sharper lens at an affordable costs with good wide aperture and things like that. So, and we also expect a lot of innovation in the sensor space, because we think that people still keep improving in terms of pixels, not only backside illuminated pixels. There are a lot of new things coming up. This revolution that is coming, that is actually happening in front of our eyes, in terms of the hardware computer vision capabilities, that will transform the industry in a great way. And of course, last but not least, video compression will help to deal with the growing resolutions, growing number of frames that people would like to see. I believe that HEVC and AV1 will be happening very, very soon, and my personal opinion that AV1 would be more applicable for streaming use cases than HEVC, even though HEVC had a head start. And with this all amazing technology, we really like, I think the key thing we should always remember that the reason why we do this is because of our customers. We really would like to make our customers' life maybe just a little bit better with the technology we are working on. Thank you.
Thank you. You guys have
Thank you.